Hello everyone, and welcome back to our video review series here for the AP Statistics exam. This video today is the first video in the series about sampling distributions. Now, granted, sampling distributions are a pretty small part of your AP exam, but the general understanding of them and what they are is critically important for the units that follow this one. So, while this may be a short unit, the ideas that make this up are going to be really important later on. So let's jump right into some of these very quick ideas. This unit is very short, so I don't want to spend too much time, but it is important. Now, generally speaking, a sampling distribution occurs, or what it is in reality is if I take all possible samples of a given size and compute what the AP course and exam description calls a sample statistic. In reality, it's taking every possible sample of a certain size and computing the mean or proportion and then placing that on a histogram. The weirdest thing about this for people is that now when you're looking at this histogram, it is not a histogram of individual people, but rather the average of some groups of people. And so to kind of demonstrate what I mean by that, I have this demonstration here. And so for this particular case, looking at this demonstration, the gray thing up here is your population. And so if I'm going to take a sample of size 5, I'm going to pull 5 people from the population. And the mean of that data set now becomes 1 point on my sampling distribution. And I can do this again. I get a second point. So every time I do this, I get a new point on my data set. Now, theoretically speaking, I would have to do this for forever, which is why you see the options for 10,000 and 100,000 here. So if I do that, hopefully now you'll see here that this distribution does look similar to my population, but it is less spread out. And so the beauty of sampling distributions we'll talk about later on, but this is just one quick demonstration about what it is and then essentially what it looks like for the purposes of this. Some important formulas. Right? If you noticed in that demonstration, that mu sub x bar, anytime you see a subscript of x bar or p hat, that's talking about the sampling distribution. Any of the standard Greek symbols like mu or sigma are talking about the population. So in this case, mu sub x bar is the mean of my sampling distribution, or the way that I like to think of it is just the middle of my sampling distribution. So this is saying the middle of my sampling distribution is equal to the population mean. And we talked about being less spread out. Well, in this particular case, we have sigma sub x bar, aka the standard deviation of my sampling distribution, equal to the population standard deviation divided by the square root of the sample size. And so the bigger the sample, the less spread out your sampling distribution gets. And that makes sense because the bigger my sample, the more confident I am that my sample mean is going to be close to my population mean. The smaller my sample is, the less confident I am that my sample mean is close to my population mean. So these formulas in my head make sense. That is the basics of what is a sampling distribution. That is it. This is probably a 4-minute video, and a minute of it was me introing it. But in the second video, the next one coming up, we will talk about probably the most important thing for the rest of our class, which is the central limit theorem. But you needed to know this for that to be important. So I hope this was helpful, and I'll see you in the next one. Bye, guys.